Hello, my name is Stan Swartz. I'm an electronics engineering technologist and a member of the Confined Space Robotics team. Confined Space Robotics, or CSR, is a Spence corrosion services company based in Leduc, Alberta, Canada. CSR's mandate is the development of industrial robotic solutions designed to reduce and eventually eliminate the requirements for humans to enter dangerous spaces and to support the good health, efficiency, and quality of industrial workforces. Our field experience uniquely positions us to understand and confront industrial safety issues. In particular, this presentation will address the challenge of sandblasting in situ assets in preparation for corrosion protection. We would like to introduce you to the CSR ALPHA1-SB robotic system. CSR has integrated independent software and hardware products to create the CSR ALPHA1-SB, a robotic arm designed to operate industrial tooling in confined, dangerous, and hard-to-reach spaces. The drive behind the creation of the SB version of the system was to reduce worker exposure to lead-based paint and the hazardous task that is abrasive blasting. The result of this cutting-edge technology is the world's first autonomous grit blasting robot capable of operating in complex environments. The CSR ALPHA1-SB system is comprised of the mechanical arm and tool head pictured on the left. It has 6 degrees of freedom. It includes a vision sensor for mapping and a tool mount that holds the blaster nozzle. The center image shows the operator control terminal. It is the software planning and control interface of the system, allowing for safe operation and monitoring at a distance. Both the CSR ALPHA1 and the operator control terminal are connected to the safety control unit pictured on the right. This compact unit contains the power and safety subsystems. A minimum of 6 axes is required in order for the attached tool to maneuver in tight spaces and around features such as tabs, hangers, pipes, and I-beams. The autonomous path planning and blasting algorithms are central to the system's ability to effectively and efficiently prepare assets for follow-up processes such as coding applications. This powerful software system allows for flexible project customization and robot selection for tailored applications. For the field operators, the CSR ALPHA1-SB system minimizes the requirement to enter confined and dangerous spaces, reducing their exposure to both acute and chronic health risks. The system's ease of use reduces the technical training requirements for operators. With the CSR ALPHA1-SB, the improved blasting safety, time, quality, and consistency of the blasting process enhances a blasting team's agility, productivity, and well-being. It also reduces rework after the quality inspections. The image on the left shows the current traditional method for sandblasting confined spaces, which puts people's health at risk and requires another person assigned to safety watch. This method typically requires 3 to 4 people, a blaster, a safety watch, an equipment manager, and a foreman. With the CSR ALPHA1-SB, the team can be reduced to 2 to 3 people by eliminating a full-time safety watch. In this example, the area above the I-beam was done by the CSR ALPHA1-SB. It clearly shows a consistent blast profile without any blotchy areas. Comparatively, the bottom area was done by hand, and the quality is inconsistent and will require some rework to achieve the desired surface profile. These irregularities are typically the result of poor visibility in the blasting area. Once the system is in place, it's a case of scan, plan, and blast. The inset image in the video is what the operator sees on the operator control terminal during scanning. Here we can see the system is scanning the environment by following an optimized scanning trajectory. Once scanned, the system registers the model data with the scan data to localize itself with respect to the blast target. The system then automatically generates the optimal blasting path that the robot will follow, shown here by the white lines. Here the CSR ALPHA1-SB is executing its self-generated plan. The 6 degrees of freedom allow it to reach the various sides and angles of the complex geometry. This video is accelerated, not actual speed. The operator control terminal allows the technician to preview the generated blast path before starting the operation, ensuring that there is full coverage. The preview speed is adjustable. Here we can see that it is set to 12 times the normal speed. The technician can also monitor the angle of attack, distance from target, the speed of nozzle travel at any point on the plan. The CSR ALPHA1 system can be utilized in many environments and industries. It has been successfully deployed in areas such as bridges, storage tanks, ships' hulls, and fixed base setups in asset maintenance or production shops. This is the CSR ALPHA1-SB set up to blast interior storage tank walls prior to the recoating process. This is an example showing the system surface prepping the interior of a rail car for recoating. The flexibility of the system allows for platform customization to adapt to virtually any scenario. A 7th axis can be added to allow for longitudinal movements, for instance along the length of a steel pipe or a concrete sewer. For larger projects and surface areas, such as an oil rig hull, 8 axes can be used. Here we can see the system controlling the 2-axis gantry in addition to the 6-axis manipulator. Future products will expand the reach and capabilities of the CSR ALPHA1-SB. CSR is working to design and manufacture a suite of cooperating systems that will further increase safety, agility, and cost savings. For example, a tracked version of the SB platform, pictured here, an autonomous vacuum system for removing the blast debris, and a coatings applicator, the CSR ALPHA1-CA. Thank you for your time and attention. At this point, we are happy to answer your questions about the CSR ALPHA1-SB and its applications.